Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know what we are doing in this playlist, we are solving all those questions which are interrelated to each other. That like the concept that we are using in the or the processes that we are using in the first question, we can use like we will be using that or the similar concept in the upcoming question as well, so that we can able to build a pattern and able to retain those standard processes and method for the long period of time and able to solve the question in the interview as well intuitively. So let's try to solve this question as well. So here we have to find the continuous subarray. We and the element in those subarray in that subarray should be closest to this integer, and the number of element in that subarray should equals to the value of k. So this is what we have to do here. So how we can solve this, let's see. So obviously we will be using two pointer approach here as well. Now let's take this array as an example: 1 2 3 4 5. So 1 2 3 4 and 5. Now what we have to do, we have to find suppose we have to find three integers whose are closest to x is equals to 2. So how we can do that? For that we can use two for loops, and then we will try to find the starting index from where we have to take that subarray. So why we are doing this? Because we have to find the number in the continuous subarray, and we have to find the starting index which is closer to this x is equals to 2. So and we have to find the closest one, and then we will take another element which are just on the left side of it, so that the difference or the distance between x and the element and the element should minimize. So that's why we have to move to the right side of that index. So our main goal is to find that index that is closest to this x. Then we will move to the right side of that, and we will take the element less greater than that. Otherwise, if we are finding we will able to get that element which is farther than x, then we will move to the left side. So this is the approach. If you like have solved the question on binary search, then this is the same concept that we will be using here as well. So I would suggest that you can watch my video on binary search, which I have uploaded in not in this playlist but previous playlist that I have made. You can watch, or you can watch it from anywhere on the YouTube, or you can solve the question from the documentation as well. Okay, so let's first make two pointers. So start will be pointing to 0, and then end will be pointing to last element, so array dot length minus k. So why we are subtracting the k? Because let me tell you. So suppose we are in this array. So if we want to move to the right side, then we should have k element left into the array. Otherwise we will not able to find next k element, uh, as we are using binary search approach. So we have to move our left pointer, and then we have to find k elements. So if we will not left k element in the last, then we will not able to find next k elements. So that's why we are subtracting it from the end value, and then we just have to use an while loop. So start should be less than end, and after doing this, while start should be less than end, and now we can find the middle index as uh, we have to do in the binary search. So mid is equals to start plus end minus start divide by 2. So this is just a way to find the middle index. If you will try to put the if you want to find the middle index of any of the sub array or the between the number, then you can put the value and you will get the correct answer. So this we have done so that we will able to uh, optimize this, otherwise it will exceed the integer value for the large value of starting and ending index. Now we have to just check if the absolute difference of the current element should, if that is greater, then we just have to move the right to the right side so that we can minimize the distance. So array and then middle, So this array middle should be x minus array mid if this the difference is greater than array mid plus k, array mid plus k if the minus x. So this difference, or this is the formula just to calculate the distance between 2 points, that is x minus array mid or array mid plus k minus x. So this mid plus k is the element. If we will take here 3, then this will going to be 4. So if the difference of this is the closest element to x, then we will move to its left side, otherwise we will move to the right side, so that we can minimize the distance. So that's what we have to do. We have to pointer start pointer to mid plus 1, and otherwise what we have to do, we have to pointer end pointer to the mid value, so that we will move to the left side of the array. And now after doing this, all the element, this middle, the starting index is pointing to the required starting index that we want to find. And now we will just add the element from this index to the kth index. So for that we can use for loop. So for int I is equals to, that will going to be start, int I is equals to start, and then this I should be less than, I should be less than uh, array, sorry, this I should be less than left plus k, because we want to add k elements. And now we just have to increment this I as well, so I plus plus. And now we just have to start copying the element to a result array list. So result dot add, and that will going to be array I. So this will copy all the elements from the starting index to the kth value. Now we just have to return this result array list. Now let's try to run this. So let's, this should be start plus k. Now let's try to run. Oh, so we haven't made an array list, so let's make that as well. So array list of integer, uh, result is equal to new array list. Okay, now let's try to run. Okay, now let's try to submit it as well. Okay, so we have successfully solved this question. So here we are just using two pointer or binary search approach, so that two pointer with binary search approach, so that we can able to find the starting index from where we have to start adding elements from the array to a result array list. And for finding that starting index, we are using this binary search approach, so that we can find that starting index efficiently and start adding elements. So thank you, see you in the next video, bye.